Hello everyone, let us talk about stoichiometry. Stoichiometry comes from the Greek words stoichio, meaning element, and metry, meaning measurement. It is a branch of chemistry that deals with quantities of substances in chemical reactions. We try to consider the chemical reaction involving ammonia, oxygen, to form water and nitric oxide. The coefficients of the balance equation are 4 for ammonia, 5 for oxygen, 6 for water, and 4 for nitric oxide. Okay, so these coefficients are important. With stoichiometry, we find out that coefficients like this, 4, 5, 6, and 4, convey the ratio of substances needed for a reaction to occur in terms of mole to mole ratio 4, 5, 6, 4. Meaning 4 of ammonia, 2 is to 5 of O2 to form 6 of water and 4 of nitric oxide, or 4 is to 5, 5 is to 6, 6 is to 4. That is the mole-mole ratio. Okay, 4 is to 5, 5 is to 6, 6 is to 4 can mean either 4 molecules of ammonia reacting with 5 molecules of O2 to produce 6 molecules of water and 4 molecules of nitric oxide, or 4 moles of ammonia to react with 5 moles of oxygen to produce 6 moles of water and 4 moles of nitric oxide. Now, to make it clear, naglagay ako ng table. Okay, 4, 5, 6, 4. Because you're given a situation where you are asked how many moles of water are produced if 2 moles of oxygen are used. But you have the ratio already, but you are only concerned with this ratio between oxygen and water. It's 5 is to 6. What will be if you are given only 2 moles of oxygen? Your problem is how much or how many moles of O2. So this is your X. Now we set up 5 is to 6 from here, and 2 is to X. Now, I'd like to remove this colon and change this, replace it with an equal sign. Yun. So that I have set up now my equation, and I will rearrange it so that X is placed on one side. Okay, so you have now, this is the given, and this is your conversion factor. That is the mole-mole ratio, which is a conversion factor. In another slide, ito yon. Okay, this is the given, this is the conversion factor, and this is now the answer. Okay, so take note, you are asked how many moles of water can be produced with 2 moles of oxygen. So this is going to be your given, your conversion factor, and this is your answer. Okay, so take note, your given is moles of O2. Conversion factor should cancel out mole of O2 so that it will lead you to your desired value, which is mole of H2O. Ano yung nangyari doon? Okay. Okay. Notice that a correctly balanced equation is essential to get the right answer. Another problem. Okay. As in the same reaction, still in the same reaction, but another problem. How many moles of NO or nitric oxide are produced in the reaction if 15 moles of water are also produced? So it's between water and nitric oxide. So it's the ratio 6:4. Okay, so 15 mole of uh, water. You have there the 6:4. Your conversion factor should cancel out mole of water. And you have 10 moles of nitric oxide. Situation number 3. Still in the same chemical reaction. This time, you are asked for grams. Grams of water. How many grams of water are produced if 2.2 mole of ammonia are combined with excess oxygen? Okay, so we need to express in grams. So, kapag mole, you have it to be expressed in grams, anong gagawin? You need the molecular weight. Okay, so the given is 2.2 mole of ammonia, and our problem is water in mass of water. So that is the given, 2.2 mole of ammonia. The mole-mole ratio is 4:6. Okay, so you have your conversion factor set in such a way that you need to cancel out mole ammonia and mole ammonia. Okay, so ma-cancel out yan. Then, since mass of water is what we are asked for, we need to multiply with molecular weight of water. Okay, the mole will cancel out, and what is left is gram unit. So that will give us 59 grams of water. Okay, situation number 4. You are asked for mass of oxygen required to produce 0.3 mole of water. So mass of oxygen and water. So the relationship is between oxygen and water. Pasensya na, maingay ang mga aso ko. So 3 mole of water. So that is the given. The conversion factor set in such a way that you cancel out water. Water in the numerator, water in the denominator. Naririnig niyo ba mga aso ko? Okay, so cancel out water, then molecular weight of oxygen, cancel out mole, and the answer is 8 grams of oxygen. Okay, situation number 5. How many grams of nitric oxide is produced if 12 grams of oxygen is combined with excess ammonia? So between oxygen and nitric oxide. 12 grams of oxygen. Conversion. Okay, since this is grams, you need to convert it to mole first. Okay, so magiging mole yan. Maka-cancel out ang grams. Then the conversion factor, 4:5. Tingnan nyo. Mole sa numerator ng oxygen, mole sa denominator ng oxygen. So that they will cancel out. Okay. Then, since what we are asked for is grams of nitric oxide, you need the molecular weight of nitric oxide. And cancel out moles to give us 9 grams of nitric oxide. Okay? Moving along with stoichiometry, we always use the same type of information to make the jumps between steps. Okay, from grams of X to moles of X, moles of X to moles of Y, and moles of Y to gram. So what do? Kapag grams of X to moles of X, you need molecular mass. From moles of X to moles of Y, you need mole ratio from the balance equation. From moles of Y to grams of Y, you need molecular mass of Y. Okay, so many stoichiometry problems follow a pattern. Grams of X to moles of X, moles of X to moles of Y, moles of Y to grams of Y. We can start anywhere along this path depending on the question we want to answer. Notice that we cannot directly convert from grams of one compound to grams of another. Instead, we have to go through moles. Pagiunsa sa moles. Okay, so steps in stoichiometry. Balance first. It is important that you balance first the equation. Write what is given. Convert to moles of chemicals given if not already in moles. Calculate mole ratio and set up as a conversion factor to convert to unknown chemicals. Convert out of moles if problem ask for unknown chemicals in different units. Convert out of moles if problem asks for a known chemical in different units. And so for your assignment or for your quiz, you need to try this out. Still about ammonia and oxygen. First problem is how many moles of water can be made using 1.6 mole of ammonia. What mass of ammonia is needed to make 0.75 mole of nitric oxide? And the third is how many grams of NO can be made from 47 grams of ammonia?